Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. And first of all, welcome new subscribers. Thank you so much for doing that. I really appreciate it. In Creating Math Ahas for Parents, I try to explain why you're seeing some of the things you're seeing when your children are learning math this year. And in August, I've been doing a series that looks at key models that you may see your child using, and they're being used to help your child understand the math that they're learning. The first video, we looked at base 10 blocks and unifix cubes and multilinks cubes and how those are used. In the next video, we looked at 5 frames, 10 frames, and partial 10 frames. And in this video, we're going to look at part-part total charts or total part-part charts and equal grouping charts. And in each of these, I hope you'll see that these are purposefully used to help your child not just get answers to the math problems they may be given, but build understanding that will serve them well as they progress through the elementary school grades into middle school and high school. And in some cases, some of the models that we use are those that will build that algebraic foundation that we want them to have. Now, in this case, again, we're going to look at a part-part total chart or total part-part, and you can see it just depends upon how it's turned, equal grouping charts. Okay, now in the description below, I'll try to leave links to other videos, the playlist, which you might find videos that are more specific to your children and what you're interested in there, explain a bit further about some of these ideas I introduce in this video. So we're going to look at a total part-part chart first. Now, here's one version, and here's a second version. And you can see the only difference is how wide this panel is at the top. But total part-part with this orientation, part-part total this way. And essentially, what we're using this for is to help your children learn how to decompose numbers. Now, you may see that term and think, what the world is that? It's really separating quantity and numbers into 2 or more parts. Getting them used to the idea that you could break numbers up. So let's say I start with 7 of something here, okay? And the idea with this is that your child will just split these into groups. I could put 4 in this group and 3 in this group. So what's one way to make 7? And you might see something being written such as 7 is the same as, here, I'll move this up a little. 7 is the same as 4 and 3. Now, did you notice my language? I didn't read this 7 equals 4 plus 3. It would be nice in story problems if we could always use those symbols, but we don't. So we want to use language when we read symbols that builds the meaning of the operations, the meaning of the symbols, and it's the language of story problems. So we can make that connection for them. So I could say 7 is the same thing as 4 and 3. Start again. I could do something like this. Oh, 7 is the same as 1 and 6. And notice I'm using words same as when I'm talking about equality. Excuse me. Now, I know I've got 7 up here, so I'm just going to write a 7. Put the 7 here. There's my total. I've been splitting it apart into 2 groups. Now, let's say I have something like this, right? What's 7 minus 5? I can hide part of it. Oh, 2. What's 7 remove 2? 5. Okay. If I have 2 and I'm trying to get to 7, how many more than 2 is 7? How many fewer than 7 is 2? And now we start to see something that might look like this. Or, see, we can use this to introduce missing addend type problems. Or look at a way that I'm thinking about how many fewer than 7 is 2. Okay, so I can use this with single digits like 7. I could use this with multiple digits, and we bring in maybe the base 10 blocks, right? So I might have 47 here. And I start to figure out how I can separate 47 into 2 groups. So it's the same idea. We can just build up. I could put fractions up here and separate fraction pieces into the 2 groups, decimals. So it's just building the idea that I can break up numbers into 2 or more groups. Now, total part, I'm starting with the total. I'm practicing decomposing the total. I turn it around. Now I've got a part total chart. So you see, it's not any new device. It's just using that same chart in a different way. In this chart, in this use, we're usually having the parts. It's more of an addition model for us. I have these 2 parts. What's my total? I slide them down. I get the total. Okay. Now, what's important is, when we looked at base 10 blocks, the orientation of the blocks isn't important. I could put some 1s in here. I could turn this sideways. It doesn't change the value of the blocks. These are 10s, these are 1s. This is a 10, these are 1s. And what's really important for your child to understand is that when we combine these two, when we add these two, 10s go with 10s and 1s go with 1s. So you have that idea. And then as I started to show you, let's say I'm going to go back to this one. I know I have a total. Let's do 47, I think was our total. I know I've got 32. Or let's start with 30. No, let's make it interesting. Let's start with 39. Now, typically 47 minus 39, right? Or let's do 29. 47 minus 29 is a regrouping type problem. We'd have to do exchanges to figure out. So we'd have to do something here to remove but this is a counting up strategy we're showing here. I've got 29. How many more than 29 will get me to 47? Here's my missing part, my missing addend. Later, they might see a letter here, an unknown, an A, an X. It looks more algebraic, but the concept doesn't change. So I've got 29. If you've seen the 5-frame, 10-frame video, you'll see I'm using that arrangement here. But I'm going to count up 47. So I've got 29 and 1 is 30, 40, 41, 42, 43, 44, 45, 46, 47. Okay. So how many more than 29 is 47? Well, I've got 18 more. Okay, so 18 goes in here. And it's a counting up strategy. And that strategy works whether it's whole numbers, 2-digit, 3-digit, or it will work for fractions, counting up when we're subtracting fractions. It'll also work for decimals. So same strategy, model. I can extend right up through the grades with this. Part total chart or a total part chart. Depending upon how it's turned, you may hear it called 2 different names. Essentially, it's the same chart. So that's one of the ones I wanted to look at. Now, it's really a variation on that idea, is our equal grouping chart. As your children get into multiplication, this chart becomes more helpful. And the idea is that I'm going to do 7 again here. And in the 5-frame, 10-frame video, I showed you something that looked like this. What is 3 7s, 3 5s, and 3 2s? Well, this is one of the other ways to work with that. Here's 1 7. And the reason for organizing it in some way, it could be a domino dot image. Here's a 5-frame image. The reason we're doing that is I don't want your child to have to repeatedly count everything. I also don't want them relying on a count all strategy, having to count each of these by ones. I'm wanting them to see the 5s and the 2 in this case. What is 3 groups of 7? 3 times 7? Well, 3 7s is the same as 3 5s put together with 3 2s. Okay, this is the distributive property we're starting to build. I could have done it as the same as 3 4s put together with 3 3s. And your child starts to see that no matter how I organize it, this final product will be the same. So it's an equal grouping chart. I'm just showing you 3 groups of 7. And what happens with this is your child slides these down to get the total. 3 groups of 7 is going to be the same thing as 21. Now, equal grouping, a multiplication model, okay? I can use this and leave this like this and turn this into a division model. This helps us build, just like the part total chart could do. Part total, total part builds the relationship between addition, subtraction, right? I can separate into 2 groups, kind of a subtraction, and addition, the inverse operation. Here, we started with the multiplication model. I turn it around, and now I'm separating into equal groups, a division model. Now, let's say I had asked your children how I could make the same quantity using fewer pieces. And that would be actually taking out, we've got, I'm going to replace 10 of these with a rod of 10. And these 10 with a rod of 10. And now I've got the 21. The trick is I want to separate 21 into 3 equal groups. And your children who don't necessarily focus in on quantity, which we want them to do, will just look at the pieces and they'll put a piece in each group. They've got 1 piece in each group. See, that's not what division is about, right? It's the same quantity in each group. So it really serves me better to work with this using these blocks, right? So there's my 5, 10, 15, and 20, and then separating them into 3 equal groups. Now, I'm showing you this with a number like 21. I could do the same idea, just like we did with the total part chart or this. I could have put, let's see, let's try 32 in each group. See, what is 3 groups of 32 made up with? Of 3 groups of 30 put together with 3 groups of 2. Same idea. I slide it down. I've got here 3 30s, 90, 3 sets of 2, 96. I can combine them. That's fine. Multiplication model. The inverse of multiplication, kind of the undoing of multiplication, division, or vice versa. How do I separate this into 3 equal groups? And I start to see that relationship. So I don't just show multiplication problems with this. I can start to show the relationship. So I can still do distributive property as we did here. But think about if I have 3 groups of 32, right? What did I end up with? 3 groups of 30 put together with 3 groups of 2 when it was turned the other way. Now I have 96. This ended up being 90 plus 6 or 96. What happens when I take 96 and separate it into 3 equal groups? I end up with 32. Okay. Distributive property can be introduced quite early if we're attuned to how they're organizing those counters within the pieces. So I can do it quite easily there. I can introduce distributive property, the same idea here with the 5-frame representation. I can use this with 2-digit numbers to show single digit times 2-digit. I could do it with 3-digit, right? I can play around with this and do this with fractions, 3 groups of 1.5. What's 4.5 separated into 3 equal groups? I can still look at inverse operation as your children move into decimals and fractions, okay? So you may see a total part chart being used to help your children make sense of addition, subtraction, combining like size units, tens with tens, ones with ones when they're adding, right? I combine like size units. You might see the chart this way, where they're decomposing numbers into parts, and this one just limits to 2 parts. It could be more than 2 parts. Or you may see an equal grouping chart, where using this, we can link division with multiplication, the inverse operation of it, and think about what's different between multiplication and division, or multiplication and addition, is you could have multiple groups, but the same quantity has to be in each group. And then as they go up through the grades, they learn how to handle remainders. So I hope that helps give you an idea of why you may be seeing these models used to help your child understand the math that they're learning this year. If you found this helpful, please consider subscribing to the channel, share this video with others. Click on the notifications bell so that you'll receive notifications when other videos post. Typically, they are posted on Tuesday afternoons, but there may be an odd video that's shared at other times also. Again, check the description below for links to our playlists, for different playlists that you might find helpful. And I hope to see you in other videos. Thanks so much for watching.